myself Raut, and today I am going to teach you the very important topic related to NEET and CET, which is current electricity. It has near about 8% of weightage in both the exams. So today we will take introduction about the current electricity. Actually, the name current electricity, you know current. Current electricity or electric current is the very basic thing. First of all, I will define you what do you mean by current. Everyone know it is a very basic and common thing, that is current. Actually, the rate of flow of charge through any conductor is nothing but current. So the question arises, whatever charges. Charges are it may be positive, it may be negative, different types of charges, positive and negative, that is such as electrons are negative charges, protons are positive charges. Sometimes I think in semiconductor there are holes and electrons are mobility charges, and motion of such charges is nothing but current. Okay, so actually the SI unit of current is ampere. The smaller unit of current is also, we know, milliampere, microampere, nanoampere. These different units we use for currents. Actually, current is, the formula for electric current is given by I is equals to Q by T, where I is the electric current, Q is the electric charge, and T is the time. We can say that it is also written as N into T. What is this N, E and T? You know, N is the number of electrons, E is the charge on electron, and T is the time. From this formula, we can find easily the unit of current. We know charges are measured in coulomb and time is measured in second. So the unit of electric current called as coulomb per second, or it is also called as ampere. A, or we can simply write it as ampere. The SI unit of electric current is coulomb per second or ampere. Okay. So we also know here we have told you Q is the amount of charge or charge, and T is the time, where N is the number of electrons and E is the electronic charge and T is the time. Okay, so how you can define 1 ampere from this formula? Suppose you have been asked in exam, define or write the definition of 1 ampere. So from this formula you can easily say that if 1 coulomb of charge flows in 1 second through any cross section of conductor, then the current flowing through that conductor is called as 1 ampere. This is a very simple definition of electric current, 1 ampere. So current, there are different types of two types of current, which is, we can say that AC current and DC current, or we can also call it as steady current. So AC current varies with time, and steady current does not vary with time, means it is independent of time. So these are two types of current, which is called as AC and DC. So after this very small and short discussion about the electric current, we will move our further topic, which is also very fundamental topic. Every student of 11th and 12th science knows this topic, that is called as Ohm's law. Actually, you are thinking about that, why sir has taking so much of very fundamental concept here? Because of that, without this fundamental concept, we cannot move forward in this topic, because this topic contains very much important bits such as Kirchhoff's voltage law, Kirchhoff's current law, potentiometer, Stone's-meter gauge, and so many topics that I will cover later on. For today's introduction, I have taken this important article, that is electric current and its units, SI units, its definition of 1 ampere, and one more thing, that dimension of electric current is given by this equation, that is 0 in mass, 0 in length, and 0 in time, 1 in current. This is important aspect. Sometimes exam you have asked the question, write the dimensions of electric current. So in this in such a problem the dimensions of electric current is given by, you can read it like 0 in mass, 0 in length, 0 in time, and 1 in current. So this is the dimension of electric current. So after this very fundamental article, we will move toward our very important article, which is called as Ohm's law. I think every one of you have this much of idea. It is very fundamental. So we will move towards our next article, that is Ohm's law. This is very important law in current electricity, because with the help of this law you can calculate values of current and voltages in a given complicated circuit. Without this law we cannot calculate the potential drops, or we can say that electric current in a given electronic circuit. So this law is given by Ohm's, so that is why it is called as Ohm's law. So what is this law? I will just tell you orally. I will not write on board because it's a simple law, and it is for saving time. I am just taking this orally. If the physical state of the conductor means physical state means length, area of cross section, material, and temperature. If the physical state of the conductor remains constant, it means that, I will once again repeat, area of cross section, length, temperature, and material remains constant, then the current flowing through the given conductor is directly proportional to the potential difference applied across it. Suppose I will explain this law with the help of circuit diagram. Suppose I have a conductor and its resistance I have indicated by R. Suppose I have applied a potential difference to this conductor. Suppose this is the same, we can say it is E, this is plug key K. You know, suppose this is a conductor which has a resistance R, and if the physical state of this conductor remains constant throughout the experiment, I have told already you that physical state means what? Then the current flowing through this conductor is directly proportional to the potential difference applied. So if you change this potential difference, means if you increase this potential difference, then current flowing through the conductor increases. If you decrease this potential difference across this conductor, then the electric current flowing through the conductor decreases. Means V is directly proportional to I. V is directly proportional to I. Or we can convert this proportionality into equation, and when we convert proportionality into equation, then we have to take a constant, and here we have taken the constant R. What is R? R is the constant of proportionality, and it is also called as the resistance of a conductor. And the formula for R is given by V upon I. Okay, and this is called as the resistance. So what is the assignment of resistance from this equation? So we can say that V is measured in volt and I is measured in ampere. So volt upon ampere, or it is also called as ohm. So the SI unit of R is volt per ampere, or simply ohm. So this is regarding to Ohm's law. Means the current flowing through the conductor is directly proportional to the potential difference if the physical state of the conductor remains constant. This is very much simple law, and from this law we have got the equation V is equal to I into R, where I is the electric current, R is the resistance of the conductor, and V is the potential difference. And we also got the equation for resistance, that is equal to V upon I, and its SI unit is ohm, and this is particular about Ohm's law. Some conductors are some substances are ohmic conductor, some substances are non-ohmic conductor. You also know, if any material or substance follows Ohm's law, then the current flowing through that conductor is as a straight line. The graph of current flowing through that substance is a straight line with potential difference. If you have such VI graph for a given substance, then we can say that conductors are called as ohmic. For a substance which doesn't have a straight line graph between voltage and current, then if you see these two different graphs, in this graph there is a straight line, means this substance follows Ohm's law. So therefore that substances are called as ohmic substances. And here you see in this graph a substance does not follow or follow the Ohm's law in such a fashion, means here the current is not directly proportional to the voltage applied. So such substances and the substances which having such type of graph are called as non-ohmic substances. Such as semiconductor are called as non-ohmic substances. You know semiconductor, it is very important. I think it is the part second, it is a topic from physics part second for 12th science. In that semiconductor you know P type of semiconductor, N type of semiconductor. Those semiconductor does not follow Ohm's law, and the graph for such substances are non-ohmic. So with this very short introduction about Ohm's law and electric current, we will just skip this article and we move towards our next article, which is very important as a point of view exam. That is, you already all of you know that is Kirchhoff's laws for electric current. Why we use although we have having Ohm's law for calculation of current and voltage in a given circuit, then also we use Kirchhoff's voltage law for calculating values of voltage and current in a given circuit. So why it is necessary? Why it is necessary to us? We will just discuss in our next lecture. So we move towards our next lecture.